I have in the middle of the state.
I did.
Not at
Good evening, everyone on the internet. We're going to be getting started in about 4 minutes.
The heck is this all about?
Now it's left and right. That's my old one.
So how does this work? Where is it? Is there a pointer?
Pointer is this.
Right, I said it was folded.
Yes, that's correct.
So make sure you're not pulling any fancy stuff here. Up and down, up is forward, left is backward.
Yes.
Okay. I just ain't missed anywhere. Oh, that's. Well, hello, everybody. We can hop in our seats here and get the meeting started. Thank you all for coming out tonight. And welcome to the April meeting of the DVAA. And so tonight, starting off with, the picture tonight is the Dolphin Nebula, which is probably the most 3D nebula I can think of. So cool. Every image I see of this, it just comes out at you, it now comes right out at you. It's really neat. That's from Steve Haas. That's from the Starfront Observatories in Rockwood, Texas. Several of our members now have telescopes down at the dark site down there in Texas, and they've had some cloudy skies like we had lately, but these have a little success there, so I like that picture as well. Okay, now I showed a picture like this last month with Venus and the moon. I'm kind of obsessed by this. It's so beautiful. Right there is really beautiful. May 18th, the crescent moon very narrow. It's gonna be right next to Venus. A pair of binoculars helps a lot to see the Earth shine and everything. So that is a really fun event to see. On the 19th, you can see it's between, Jupiter and Venus, and then it kind of goes up towards, makes a straight line with Pollux and Castor. But the 18th is the night that is really the night to try to get out there and see it. Whoa, okay. So spring is galaxy season. Now it's prime time galaxy season. We gotta get serious to go out and observe. And so where are these galaxies? They're right almost on the meridian at 9:30 at night on May 1st. That's really the circle is the main area where they're concentrated. There's a whole group around the Big Dipper and just a little bit south of it. And then of course you have the Como Virgo with the Bernice's hair, the back of Leo, Virgo, where it's just really real clump here and a big clump here. But there's galaxies throughout this whole area. I think the Pocket Sky Atlas from Sky and Telescope has over 300 galaxies plotted within that circle. I mean, it's just a tremendously busy area. But that's a fun thing to look for. Okay, last chance for Jupiter. This is the last call. May's the last really good month. At 9 o'clock on the 1st, I think it is. It'll be about 45 degrees above the western horizon. Still nice and high, good observing. But by the end of the month, it's only going to be, by dark, it's going to be just a little bit above the horizon. So it's going to be a lot more turbulent down there and not going to be quite the Jupiter we know. So this is it. If you haven't seen it much, this is the time. And you can check the Sky Live site down here and check when the satellites are crossing like this one is, and you can look for the shadow. The shadows are pretty easy to see. So that's something that's kind of special and kind of fun to see. Okay, now I'm going to have Jan come up, our observing chair. We have 2 Astronomical League awards. One for Dave Miskey, one for Roberta Shanner.
So thank you, Tom. This is a fun thing to do in my new capacity as observing chair. And these are really interesting awards. I'm going to tell you a little bit about them because they're so interesting. We have, I'm sure most of you know about the awards that involve looking at 100 Messier objects, more than 100 Messier objects, more than, I don't know how many Herschel objects, etc. And but these special awards are pretty different because they're very focused on a narrow objective and take you in a very fun, different direction. So these 2 members, Dave Miskey and Roberta Shaner, took these special observing challenges. And they're 2 different types. One is Dave took on an Astronomical League Special Observing Challenge. And that was to observe Comet 3I Atlas. And then Roberta took on the Hubble Challenge, which is a NASA partnership challenge. So I'm going to tell you a little bit about these, and maybe I'll get you enthusiastic about trying some of these kind of things yourself. So first, Dave's involved Comet 3I Atlas C2025N1. So does anybody remember what all those symbols mean? 3I means it's the 3rd interstellar object. So it did not come from our solar system, this comet. Atlas is the telescope that discovered it. And 2025 is the year it was discovered, and N means each of the months of the year are divided into half. And so N happens to be, I think, July. Yeah, July. And it was the first object discovered in July of 2025. That's what that strange nomenclature means. So the closest approach to Earth was December 19th, 2025. It was a MAG 9.6, reportedly. And in order to get this award, observers need to sketch or image the object, noting the equipment, and also share information with others. So Dave Miskey took on this challenge and got the award, and I'd like him to come up and get his certificate.
Want to applaud, just throw money.
There you go. There it is.
We can throw batteries.
Hey,
At least,
congratulations.
Thank you very much. And here is my C-star image of the comet. It certainly did not look like much, and visually it was just a fuzzy little dot.
Yeah.
But I observed it with the 17-inch classical Cassegrain at the Naylor Observatory with magnifications from 116 to 259x.
Wow.
And the first night that I imaged it, it was in the database of the C-star. The second time I tried to image it, it wasn't there. So I only got it the one night.
Well, thank you very much for reminding us about the Astronomical League challenges. And this is the best photo I could find, which I think yours is probably better.
Well, this.
Even this one is better. Thanks again.
Thank you.
I just read that someone looked at it very closely and it had a lot of deuterium. And they had to do with the way it formed 11 billion years ago.
Wow.
The way that deuterium had to do with the way it formed. I believe that's fascinating.
That is absolutely fascinating. Okay, now let's go on to the next award. So this is pretty much an interesting challenge too. So Roberta Shaner took on the Hubble 35th Anniversary Special Challenge. And there were some small challenges within the larger challenge, as I'll explain. So she took on she was awarded the Gold Award. And that's the pin up there that she received up on the upper right-hand corner. So over the span of 2025, she had to do 4 or more outreach activities to spread the word about the Hubble telescope. She also had to observe 4 or more objects each month from the lists and submit them each month. So just as an example for you, the monthly object list for January for the Northern Hemisphere is there on the right, and you had to find 4 of those 6 objects in order to get the certificate for January. So she repeated that process every month. She imaged the objects with a C-star. And then the fun part, I guess, one of the fun parts was you had to identify the part of your sketch or image that corresponds to a part of the Hubble telescope image, which is from an atlas that they gave you a link to. So it took a lot of dedication to do this, I think, and that's quite a good challenge. I'd like to hear about anybody else who takes on one of these challenges as you're doing it, because this sounds like a really inspiring attempt she made. And she told me that everything was local except for one of the objects. So you can do it around here. Okay, thanks. Roberta couldn't be here, but these applause are for her. Oh, for that.
Me, but it's me.
Shut it off.
It is off.
But if I speaker, then put back on.
That's all.
Put back on.
You hear that?
Yeah.
Yeah.
I hear it.
It's off.
Okay. Okay. Well, thanks, Jan. Now, speaking of the Astronomical League, there's all these different programs, and I'd like Al to come up for a second, put him on the spot here. I need his help with this. Hate to put you on the spot.
No, you don't.
But the real reason you're up here is why, I mean, this is a question everybody's been asking. Why does everybody in the world know Al Lampert? Because he's everywhere. But what has he done? 36 years of leadership. He was the president of the DVAA. the observing chair, the outreach chair, night sky network coordinator, Merrill liaison, originating director of the DVA Youth Awards, Geezer Gators. He was a mentor to his fellow amateurs. You can see some pictures of a few of the old guys up there getting certificates, helping out at a star party, inside clinics, and nurturing the younger. Look at that. I love the shot on the right because with the young person looking through a telescope, Al brought the ladder and stuff so they could get up there and look at it. And just you can see on the left there, he's demonstrating a lunar crater, I think, formation. An innovative presenter back in the 3D glasses days, back when he was president, I think. And everybody there. And a master observer gold astronomical, and that's not easy to do. You have to do so many different certificates. And this is Mondo Telescope. This is a Franks, I believe. That's a Franks, I think, that shot. Astronomical community contributor. Original publication, Sky and Telescope and the Webb Deep Sky Observer. Originator of Astronomical League observing programs, several of them. Citizen science discoveries and publications. American Astronomical Society collaborations. DVAA Lifetime Achievement Award to Al Lamperti. Congratulations, Al. We got a little something for you. There you go. That's for you. Open it up. Nope.
The new obsession 25-inch.
The compact version.
Yeah.
It's a mirror.
The ultra
Start
compact.
grinding.
Yeah.
Like the top opens up there. These open up there.
Yeah. Cool. Wow, thank you very much. Thank you. That's great.
And that's not all.
You can grind that into a mirror. Take a nice parabola on it.
Here's another little package. Put that over there. So I can see.
Do the W.
Yeah, what's the F ratio? It's 40.
And
The 22-inch.
the 22.
Saw a lot with that guy. I have to say that I've learned a lot by being a member since about 1984, and Joe and I joined around the same time. And I don't know, just keep learning every day, and learned a lot from you guys, and still always learning. And hopefully that will inspire you guys to keep coming here and suck all the knowledge you can. Thank you very much.
You deserve it, Al. You can take the bag, yeah. Right in there.
Remember, the Astronomical League ran out of observing programs, so he had to make his own.
Right.
AL and AL are
Yeah.
different things.
You know, there used to be the Chuck Norris facts. There's also Al Lamperti facts. You know, the people at the web, they call Al to confirm their observations.
Yeah. Well, thanks for everything, Al.
Thank you.
We really appreciate it. Okay, back to business now. Enough of the frivolity. Okay, upcoming events. Well, tomorrow we have a public star watch. Boy, the sky's looking good, isn't it? So tomorrow's a long shot at being clear, probably something like 1% or less. Backup date Sunday, that is a little more up in the air. It's going to be rainy up until Sunday morning. May or may not clear in time. I'm sure Joe Lamb will make the correct decision.
No pressure.
But we'll see. We'll see how that goes. So that one's on there. And then we have May 1st, full moon walk at Green Lane. This is Craig and Tracy Blocker heading this up. And it's up on the events calendar there. Evidently, the walk starts by the tennis courts, but ends, the scopes are at the end, which is by the equestrian parking lot, and telescopes are needed. Go ahead, Tracy. Oh, equestrian campground, sorry, yeah. So there's links on the website. You can click on it. You can find more about it under the events calendar. And they need scopes, so anybody can get out there. It's full moon walk, so you're probably not doing any observing at home. They're going to a dark sky site, so you might as well come out and tell people about the moon. Then in May, we have a public star watch, hopefully under easier situations to call as far as the weather. 27th is the astrophotography workshop Zoom, which we have on the Wednesday before the Friday meeting on the 29th there. Then the 30th has Radnor's Great American Campout. And I think Barry Johnson's heading this up. You the contact person? Okay. And we still need some scopes for that, I think. So if you can make that, that would be great. Then we have our first clinic of the warmer months. And that's the Green Lane Observing Clinic. It's on June 5th with a rain date of the 6th or the 7th. That's what an RD means. So we'll see how that goes. But I don't know if anything's up on the website yet, the events calendar. Jan, did you put it up?
Yes,
Oh, it
yes.
is. Okay, it is up there, so you can find some more information about it. But
Tonight.
okay, okay. But it's a good chance, for if you're just, you're new to this hobby, or you're just having trouble with something, or just want to learn more, just come out and, ask a bunch of questions, bring your scope out. If you got trouble collimating it, using a finder, doing anything with it, finding objects, bring it out. There'll be some people there who have had a lot of experience over the years. Just like we saw those pictures with Al helping people out, there'll be people out there helping. So that's the idea, is to kind of, get everybody up to speed and any confusion they have to try to help each other out here. Cherry Spring Star Party, 11th to the 14th. I don't know if that's open yet.
It is.
It is?
So
It's filled.
sold.
Yeah, I know. If it is open, it's sold. It's going. That goes in. That used to be open for like 3 months. Now it's open for like 3 hours.
Only two nights this time.
2 nights, okay. And that's from the Harrisburg group runs that. So that's where Dave and Sandy.
It was a lot of work getting it together with the state league.
Anyway, that's a star party you won't be attending unless you're already registered. But it's Cherry Spring State Park. It's a great place to go. So maybe if it's going to be clear a couple of days before, maybe go out for a couple of nights and enjoy the dark skies and get out of there before the 11th. And then we have the June 20th is our June Star Watch. So that's the events that I'm aware of. Anybody have any other events that they're want to mention? Okay. Oh, I showed this last week too, last month. May 1st, Kalamazoo group. They're a really interesting group of people. And they have their Zoom meeting. It's a 9th anniversary special event type of thing on May 1st. It's a Zoom. Anybody can register, it's free. They have David Levy as a guest speaker, and he's going to talk about a lifetime of comet searching using the night sky to support an exhilarating life. And that should be pretty interesting. So if you are not doing anything on the 1st and might want to dial into that Zoom, you have to register. But go to that link down below there, you'll see it. You'll get to it, or just Google Kalamazoo Astronomical Society and you'll find your way there.
They had a very well presented program for amateur astronomy,
Oh,
over 5
Right, they had 5 lectures. We talked about that a little bit. They did have a series of lectures just going over basics in astronomy. 5, really good. They got these guys it's a really good group. Anyway, junior board member. This is a term that runs 1 year. It's going to start running from June 1st through the 31st of next year. So we are accepting applications. Anybody who's a junior member, 14, 18 years of age. We have information. If you contact the board, we can send you what it's all about as well as an application. So it's always good to have a junior board member because they can think of activities that would interest them. It's a whole different perspective, and it's always good to have a variety of perspectives with the board meeting. So hopefully we'll get a couple of people to step up and want to be junior board members. Now the welcome report. Brian Lee.
I'm Brian Lee, welcoming chair. I'm Brian Lee, welcoming chair. Like I said, we have one new member tonight. I don't believe he's here, but Jim Hopkins.
This is where the meeting, John's not here, right?
No.
This is where the meeting might go off the rails a little bit. With this, but they'll have to go back to this slide. If it's the next slide. No, it's not the next slide. Okay, we still have a few minutes. We have a new arrival. A new arrival has come in. The C-Star S30 Pro. Joe Lamb has it in his hands as we speak. We got it a little less than 2 weeks ago. It was donated. Most of our, I think all of our smart scopes have our donations, and which is really incredible because these things, you know, they're not, you know, thousands of dollars, but they're not $100 either. So really generous members, and so I happened to get it in my hands for about for 2 nights. I used it, and now you'll go and say, "Well, that's a terrible shot of the rosette." Is the rosette, believe it or not? That's a terrible picture of the rosette, but that's only 5 minutes, and that's during astronomical twilight. So the sun just went down. I'm pulling it out. I had to shoot them because there's the tree line. Okay, good. So, and here's some images that I could pull from it. Now it's got a wide field of view. The difference between the S30 and the S30 Pro is the chip and the lens. It has a better lens. It's a triplet lens versus a double lens, much flatter field. Gary owns one. Four lenses. Gary has one, and you can notice here that, you know, that top picture is totally uncropped. I mean, the one on the left there with the rosette, all the stars are pinpoint all the way to the end. It's very nice. And but it has it's a much larger chip physically in area. It's like 4 times the number of pixels, but the pixels are still small, which is nice because this is a short focal length scope. So the pixel size is still small, like on the S30 and on the S50, but the field of view is huge. So the shots down here are actually zoomed in. They're cropped images. That's the Leo triplet. Here's the M81 and M82. This is the area around the very active area in the Como Virgo area. I think that's the eyes right in there. It's 84 and 86. Yeah, it's the bottom part of the chain there. Anyway, it's a really good scope, and it's very generously donated. Let's give a round of applause for the anonymous donator.
Gonna go up in price $100 in May.
That's right. That's another thing.
Get it now.
Right now, if you're interested, this is for what you get. It's an amazing scope, and the price right now is $599. However, May 1st it becomes $699. So if you've been on the fence about this scope, this is the time. And it joins our whole family of scopes now. We have several smart scopes now. We have the original S30, we have a S50, we have the Dwarf Mini, we have the S30 Pro. This is kind of a hybrid scope. It uses your phone. Your phone goes into a holder on this, and you have to manually move it there to find the object. But it does all the stacking and stuff like that behind it. But you're a little more hands-on with it. But it's got a pretty wide field of view, I understand. I've never used that scope though. And we have a number of visual instruments. So it's good timing. John's here. So, okay, John, I'm going to bring you up here right away. Well, I'm kind of stalling here for a second. Now, John Conrad, probably everybody here has known John Conrad for years and years and years because he's been here for years and years and years. And he has given, I don't know, 4,000 talks here probably. But anyway, was this, oh, I'm sorry. You stay here anyway. I got two more slides. You get to be a galaxy. Real quick, this is our astrophotography workshop. It's next month, 27th, 7 o'clock. It's going to be the typical show and tell questions and answers, but we're going to have a short presentation on using WaveSharp. WaveSharp replaces Registax for planetary work. So it's going to be a little bit of talk about that, a little bit of walkthrough. Won't be too long, but we'll walk through. We'll take an image from a video, we'll bring it right through to a final image. It won't take long, 15, 20 minutes, but it'll be an interesting presentation if you're interested in planetary or lunar work. To find it, just go to events, hit the calendar for May, there's the date, it has all the data with the link to the Zoom. Easy peasy.
Make sure you log in.
Oh, you have to, that's right, you have to log in as a member on the DVAA site to be able to see that event. You've got to be a member. Thank you, Jill. Okay, here you go, John. Now you're on. Now, John has been here forever, like we said, and as a result, the board has decided that John really, he's been here so much, he really should be a member, an honorary member, because he's here more than some of our members are. So, John, certificate, and it reads, for those, if you can't quite read it, it's a certificate of honorary membership presented by the Board of Directors of the Delaware Valley Amateur Astronomers to John Conrad with deep appreciation for his many fine lectures delivered to the DVAA and his dedicated contributions to the field of amateur astronomy, fostering a spirit of exploration and community. Wow. And you got an official name tag now and everything, so people will know who you are in case you don't know. There we go. Thanks, John. Appreciate it.
I can't tell you how much I appreciate it. I mean, I kind of make little jokes once in a while, but at this point, I'm very serious. This means a lot to me. I do, as you can probably tell, spend a fair amount of time preparing these talks. But the fact is, as a retired man, an older guy, OG or whatever we're called, I discovered the NASA Ambassador Program, and it frankly has made my retirement. As you're all aware, I was involved in the space programs earlier, and this gave me a way to keep up with everybody down to the age of 20 and keep up in the latest programs. So I thoroughly enjoy it, and I really enjoy preparing the talks. And I'll say one last thing. I talked to a bunch of clubs, a bunch of senior homes and so on, and some museums and libraries. The clubs go all the way up to Allentown and into Philadelphia. And I'm seriously going to say this, and I hope nobody is here except me from another club. You guys are the best in terms of your club meetings, substantive stuff, really good speakers. I'm not being immodest here. I mean, everybody else, of course. Really good. And the attendance is wonderful. It's just a wonderful club. I appreciate this honor and great to be a member.
And that went out over the internet, so it's official.
I can't take it back now, John. What do I have? Okay, okay. So, thanks for everything, John. We appreciate it. John always comes through in a pinch too. I mean, because Jeremy sometimes has to make some last minute calls, and John always comes through to help us out here. Okay, now it's time for the observing report. I want to ask Ken to come up, and he's going to talk about red giants. Thank you.
Is this working?
Yeah, I told you.
Oh, you're turning it on.
Testing.
That works.
There we go.
Cover is coming off here.
Oh, okay.
All right. Which way does this thing work? I never remember.
The normal left and right. It's the way you expect.
I wanted to talk a little bit about red giants tonight. My motivation for talking about this started many years ago. I read this book called Stardust, The Cosmic Seeds of Life. This was about 10 years ago. I read this book, and I'll stay away from that speaker. This book really captured my interest. It's really the basis of this book is really the story of red giant stars, but it actually goes, it's really not the story of red giant stars in the normal sense that us as amateur astronomers are interested as variable, really classic variable stars, as really good observation targets. My interest in this was actually a little bit different. My interest in this is really sort of the chemistry that happens in red giant stars. As a retired chemist, that's kind of what really caught my attention. Really, Sun Kwok, the author of this, is kind of a prominent infrared astronomer that really, in the last maybe 3 decades, he and a number of groups have actually investigated really what is this material that really captivates us in nebula, this stardust. And that's really the story that I'm going to talk a little bit about today as we talk about red giants. So the red giants, of course, are the end stage of stars, average stars or massive stars. And in the stage of stars, really the nuclear processes in the core of the stars changes enormously. The stars increase enormously in size. You're thinking about the size here, just to put it in perspective. Our sun at this stage in evolution will actually envelop the Earth. Some of the red giants that I'm going to show you as observing targets tonight, I think the radii are greater than 1.5 astronomical units, which, 1 astronomical unit being the current distance of the sun to the Earth. That's a big star. That's pretty big. So a little bit history here. Well, it's been postulated since the 1920s and then proven in the 1950s and 60s by nuclear physicists that every element that constitutes all matter that we know of is produced in various stages in the lifetime of stars, especially the red giant stage and then the later supernova explosions, really energetic explosions, the end life of super giant stars. It really wasn't known until very recently that stars were capable of not just making atoms, they were actually making molecules. And these red giants are very effective at producing carbon-based molecules and also inorganic crystalline molecules. So we'll talk a little bit. That's really what really fascinated me about the story of red giants. So a little bit more about stardust history. Elements, and I'm trying to keep the chemistry very light here because I know not everybody's as interested in chemistry as me. The elements like carbon, oxygen, and silicon are really produced at the end stage of stars. The end, this last million or so years in the lifetime of a star. Kind of in the human scale, this would be, say, an 80-year lifespan of a human. This would be the last couple days of your life. And this is really where they really start churning out a lot of atomic and molecular material. So it wasn't until the 1960s that infrared astronomers at the University of Minnesota, this was kind of the era where infrared astronomy was just getting started in Caltech and also the University of Minnesota. By the way, Sun Kwok originally was at the University of Minnesota, which was one of the premier infrared astronomy labs in the 60s. Now he's at the University of Hong Kong. In the 60s, University of Minnesota researchers were the first to demonstrate what really was the essence of stardust. They actually saw the infrared spectra of silicates in the clouds around red giants like Mira. Mira, I've talked about in just a minute, be one of the classical red giants that is a really interesting variable. I think it was the first variable star that was ever identified, I believe. So silicates were really thought to be the essence of what we see as stardust, you know, the nebulosity in nebulae and stuff. But actually, in recent decades, this has only been in the last 20 or 25 years, actually. Investigators like Soon and others have actually shown the spectra, the infrared spectra and even microwave spectra of dozens of complex organic molecules, carbon-containing molecules that kind of resemble, there's spectra that resemble petroleum, coal, many aliphatic, almost like fatty carbon compounds, even some biologically relevant compounds they've seen spectra of. I kind of think of soot, you know, these kind of things they're seeing in the clouds around giants like Mira. So the bottom line is it appears that red giants are really the chemical manufacturing plants of the universe, and that's what really fascinated me. By looking at these stars, I'm almost looking at sort of the industrial area of northern Delaware or maybe New Jersey. So that's maybe some of you aren't excited by that, but that kind of excites me. Anyway, a little bit more about stardust. Kind of my observation part of this was one of the classical targets to look at for a red giant. Is really not a good time of the year to look at it now, but I got thinking about this back about Thanksgiving, and I thought, you know, now that I had bought a sea star, I thought, well, this will make it a lot easier to find some of these red giants. Some of them are kind of hard to find. This one is rather easy. It's a classical variable star. It's in the constellation of Cetus, very visible in November and December, the early winter months. So last winter, I took a look for this one and easily found it. It's a star in Cetus, in the constellation of Cetus, the whale constellation. By the way, I'll put these slides up later, and you can actually, there's really good list of all these variable stars, their locations, their periods, and their magnitudes, their relative magnitudes that are available even in Wikipedia and stuff. Really nice list. Mira is also known as Omicron Cetus. I believe that's, what is that, Omicron, the 15th brightest star or something like that. It's kind of a dim star most of the time. These Mira it's the sort of prototype of the variable stars, red giant stars. Mira class red giants undergo very large changes in brightness over periods of about almost a year. You have to look long periods of time to see these differences in brightness. They're not like more rapid period variable stars that you might be familiar with, like Algol and some of the others. Anyway, Mira actually is a dual star, is a binary star system. It has a red giant with a white dwarf companion. Hard to see the white dwarf because very dim. I actually took a picture here. I don't know if you can see it. This was just on the sea star. You can see on the right, I took that in Thanksgiving last year, right around Thanksgiving, and on the left, and on the right, I actually took the same picture, the same exposure time, about a month later. And I hadn't really thought about this beforehand, but I could see that was quite a bit brighter and much more obvious, a month later. And in fact, when I went to the AAVSO magnitude chart for this, in fact, I picked the right time to look at it because I picked at Thanksgiving the first arrow. You can see that I picked it at its minimum of about a magnitude about 8.5, and pretty dim star. And then I got it at its maximum right around New Year's. So I happened to pick the right days, and that was kind of cool because I didn't plan that ahead of time. And not a good star to look for right now because it actually tracks the sun right now. So just wait till next winter to look for that one. But a good one to look I thought I've looked at a lot of variable stars playing around with this the last year or so. The good one to look for right now are three variable stars in the constellation of Leo. Leo's a really good constellation to look at right now in the month of April. Of course, one of the Leo's kind of a dim constellation, this kind of light polluted area around here. But Regulus, you can always pick out pretty easily the brightest star in that constellation. And it turns out many of the variable stars we're going to be talking about are either just a bit higher in declination or just a little bit to the east of Regulus. So that's a good starting point to look for these red giant variables. So the first one I wanted to talk about of those three is really the Gamma Leonis, or what's also known as L-Gaiba. L-Gaiba is kind of shown there circled in red. That's actually the base of the sickle, the backward question mark of Leo. That's a pretty bright star. I think it has a magnitude about 2. Very easy to pick out. When you look at it, for example, when the second I'll show you on a C star, it looks like a single star, but it's actually a binary star system, and has one star that's actually it's a red giant, but it's not a real variable red giant. It stays right around the magnitude of 2. And the other one, I can see when I use a reflecting telescope, but I don't have a camera on that scope, so I can't show a picture of that, but I can show in a C star. It's clearly a red giant star. I mentioned earlier that these stars are very big, and you can see that just in the relative size of them compared to the background stars, that they're very, very large stars. Our Leonis is the next one I wanted to talk about. This is a classic Mira giant variable red star, which is pretty easy to pick out. I actually had fun with this one because I didn't look for it ahead of time. I didn't look at a star chart to know where it was. What I decided to do, because I knew it was in that quadrant of the sky to the east of Regulus, I basically used the mosaic mode on the C star, and I just kept taking mosaic pictures about 3-degree field of views of the sky. And I like to kind of look at these patterns to see, am I seeing something? And right away I saw this red star, and so that must be R Regulus, because I knew that was one of the easier ones to find. And then I actually went to the AAVSO star charts, and I could actually see that exact pattern of background stars, and you can see that star in the center with the target. That is indeed our Leo. So that was kind of fun. I like to do these little pattern things. Anyway, you can see I actually looked at this several times, but the picture I just showed was actually taken just a couple of weeks ago. I took it again to show you tonight. It was actually taken near the minimum of that star, but it's quite bright. That actually is quite bright even at its minimum. At least when I looked at it, was at least a magnitude 8. Anyway, the last one I want to talk about is the one that most excites me, because this is the one that's been studied the most in terms of organic production of what we really think is really getting at what the heart of what stardust really is. And this is the red giant called CW Leonis. And a group of investigators at Caltech discovered this in 1969. And they actually discovered this sort of by accident. They decided to do a really broad survey using infrared telescopes, which were new at that time. They decided to look broadly across the whole sky to make a star chart. And I guess from what I read, most of their colleagues believe this is a waste of time. They wouldn't find anything that wasn't already seen with visible telescopes of the time. And in fact, they found dozens of new stars that had never been seen before, and this one being the brightest of all of them. This basically is the brightest IR source in the sky, and it emits almost no visible light. And now it's understood that the reason, not only is it a cold star because of its stage of evolution, but it actually does emit visible light, but it's completely absorbed by these enormous dust clouds of cosmic stardust around it, and that's really it. They absorb it, and then they emit it as infrared heat, and that's what you're actually seeing. So I thought it would be fun to see, well, could I actually see this star? I talked to Tom about it, and I said, well, he's got better cameras than I know. Many of you have a lot of good astrophotography cameras and stuff. I'm really cheap, so I don't spend a lot of money. But anyway, I thought, well, first of all, the problem with looking in the infrared is if you go too far, and the infrared has many regions, but if you go into near infrared, you can actually use a standard telescope. The near IR wavelengths will actually pass through the glass lenses and so on, so you can actually use those for near infrared. But if you go into longer wavelengths of infrared, you actually have to have specialized optics that don't involve glass and so on, and that clearly is out of the picture for an amateur astronomer. So anyway, I thought, well, gee, could I do this? Well, first thing I did was the same fun game that I did before. I said, I'll just use the C star and just do these mosaics across. This star actually happens to be very close to the planetary ecliptic. And I figured if I go close to that, I'll find that pattern. And right away, I found the background pattern, just sort of using 3-degree spans. I found that 3-star pattern in the circle. But what was missing was my target star, which was the CW Leo. And that wasn't surprising because the C star probably hasn't have any sensitivity. The camera, the sensor chip, the CMOS chip probably doesn't have any sensitivity to near IR, or maybe it has a cutoff filter. I don't know. Probably has a filter. So anyway, I decided, well, let's go to YouTube and see what they say. And that's the last thing I was going to talk about. I went there, and of course, I found a YouTube video where somebody claimed they could see this with an amateur telescope. So I decided, well, then it's possible. So I decided to buy, they described you could add an IR pass filter to your camera. Of course, one of the problems with it looking in the IR is you can't look visually because we have no sensitivity of our eyes to IR, so you can't look visually. You have to have a camera. I talked to Tom, and Tom has a monochrome camera that would be good, but we didn't get together. So I decided, I looked on, I guess, High Point Scientific, and they had a pretty cheap, I'm cheap, as I said, I think it was like $200 for this QHY color camera, which wasn't ideal. I should have got a monochrome camera, but it's advertised as a near IR sensitive camera, and you can see it's pretty sensitive, above 800 nanometers. So I tried a few weeks ago to make this work. I still, the principle is you put off the filter in and you block all visible light, and you can then see only the near IR light. I really couldn't see, I couldn't pick out the star yet, but I'm certainly not well trained in how to use the camera system yet. But anyway, I was a little disappointed about that. But I was actually quite excited to see, well, NASA did this a long time ago, so I didn't really need to do it anyway. So they released this, I think they did this in the Hubble days. This was actually, the Hubble telescope zoomed in on this star system, or this star system. This is really nice. I'll put the view on there. You can kind of zoom in and out. They have a really nice video in there. You can see in this video, it was released in October 2021, what we're talking about. There's these concentric dust rings around CW Leonis, and this is really what's being produced by these red giants is massive amounts of organics and silicates and so on. Just massive amounts of organic material. And this has really caused a lot of excitement, understanding what that these are capable of making organic molecules, which was unheard of 30 years ago. So anyway, to end, what is stardust? What is this stuff that we get so excited about, the beautiful views that we see in the sky? I guess I was excited to find out it's not just sand, it's actually organic and a very wide composition of chemical compounds are present in that dust. So I like this quote from the book. They said the materials that go into making you or me, as a human being, were generated in stars, which we've always heard. But they say that the dust is both our destiny and our origin. I thought that was a beautiful quote. So I'll kind of end there.
Those of you who like comic stars, your economic league has the talking star observing program,
Really?
visual or imaging.
Nice.
Yeah, in the January or February issue of our newsletter, let's say 23 or 24, I wrote an article. I went out and it was cold. It was January, February, and I decided to start hunting some of these carbon stars down, and I list 12 of them, I think, in the article, and went out and looked at all of them. And I wrote my impressions of what the shade of red was in comparison to what I read about in the literature from different sources, and it's kind of a very interesting thing. Some are really quite red, and so it's kind of a fun little thing to do. But the Astronomical League program gives you a whole list you can shoot from, not just in the winter, but throughout the year. Anyway, now it's time for Jeremy to introduce our speaker. Maybe. There you go.
Use this mic. Okay. All right, gives me great pleasure to reintroduce John Conrad, a man who needs no introduction for most of us. So John got his start at the U.S. Air Force Academy and Purdue University, earning degrees in astronautical engineering. From there, he went into a career in unmanned spaceflight, working with the U.S. Air Force and with NASA. Since then, he's retired and he's been making the rounds, doing talks on a variety of topics, including Titan, the moon, NASA's great observatories, the Lucy mission to the Trojan asteroids. He did OSIRIS-REx as well, DART, the double asteroid redirection test, and a number of others as well. So I'm especially pleased tonight to have John here to talk about lunar reflections. And he did bail us out. I had to make a few last-minute changes to the schedule, and John came in a pinch. So please join me in welcoming John Conrad.
Is this on?
You might have to turn it on.
Do I push the button?
Yeah.
Am I here?
Yes. Gotcha. Just enter there. Right.
Thank you very much, Jeremy. Quick question to start. How many of you happen to go to NEAF this year? Any of you? Saw a couple of people. It was, as I had suggested to Jeremy and a bunch of others that I talked to in the different clubs, it featured the oldest astronaut, Don Pettit. Did you hear his talk? It was, okay, it's fantastic talk this guy gives. If you ever get a chance, and probably if you go out on YouTube, or if you look at, what is it? Payload.com. Does anybody review that website? There are a bunch of websites now. Anyway, Don is famous after his now, I think, 4 missions to the ISS. The one ended with his crash down in Kazakhstan just a few months ago. Guy is tough. I mean, 70 years old and going through that sort of thing. And he is just a world-class photographer. And of course, being in the ISS, the things that he's done to look at the variety of things from orbit, contrasting, looking through the atmosphere and the limb, features in space on Earth all at the same time exposures, showing all the Starlink satellites and how they get in there, as we all hate to see. Anyway, if you get a chance, Don Pettit, look it up. He's a fantastic speaker. His talk was called Cosmic Pixels. Anyway, and he's been at NEAF now twice in the last 5 years. This particular talk, which I was able to pull up and prepare in a hurry when Jeremy called me last month, I haven't given it but a couple times. It was actually commissioned in a sense by Westchester University for the 50th anniversary of the Apollo. So it was 2019 when I gave it as kind of the keynote talk on an Apollo 50th day that they had. And so I really enjoy revisiting this stuff. I like to note somewhere that the week that Apollo 11 was launched. I actually launched my own satellite from the West Coast the same week, maybe a tenth the size of a Saturn V, but at any rate, it was all fun and games back then. At any rate, these are reflections, as in facts about what went on with regard to our programs to put man on the moon, and also my own reflections at times about what I was able to observe for context. So we'll go ahead here. We're not going to just start right in the middle of Apollo. We're going to start before Apollo and lead up to it. And so we're not just going to start actually before the space age either, which was just a few years before the decade of the Apollo. We're going to go all the way back to what I like to call the beginning of real rockets. Now, of course, the Chinese and then other nations like the US with the rocket's red glare and bombs bursting in air had solid rockets for warfare and for public displays and things like that for actually a couple millennia. But entering the 20th century, there were no real liquid-fueled rockets, controllable rockets. And so there are actually three scientists that you should know about that were the prominent ones in the first half of the century to get rocketry underway. And you can probably guess who one of them is. He's very familiar, but I'm not going to start with him. I'm going to start with one that preceded him and all the others. This gentleman here, who looks like a Cossack, and in fact has Cossack blood in him. He's a Russian. Long before there was a Soviet Union, roughly 50 years, he was born. And he lived in a wooded area 100 miles away from Moscow, very sickly as a youth. So his father actually took him out of school. So he didn't have formal schooling, but he was brilliant. And he read voraciously. He went to the library all the time. Eventually, he became a teacher and he started writing books and various kinds of research papers, became recognized by scientists first in Russia during the czars. And then by the time he would have been 50, when the revolution happened, the Akademia Nauk SSSR, the Soviet Academy of Sciences, which is pretty famous, actually picked him up at that time, a man with no formal education, because he had a vision as well as a technical understanding, and it was all self-taught. He came up with and published, as I said, many books, but this is the most famous, where reactive devices, of course, refers to rockets. And he conceived liquid rockets for the first time. He came up with the calculations to say that if you used liquid hydrogen and liquid oxygen, you could launch a 100-pound payload to 100 miles up with a speed of 5 miles per second, which happens to be, with 3,600 seconds in an hour, 18,000 miles per hour, which is exactly right. Now, he didn't even launch a rocket, let alone or test a rocket, let alone have a satellite. Did I just cut out? Yeah. And as you see there, he had a number of other ideas that he talked about in addition to just liquid fueled rockets, multi-stage rockets, hovercraft. He talked about this 125 years ago. Space elevator, I don't know if any of you have ever gone out online and read about the concepts for this, but it's just what it says. It's a physical elevator built to orbital altitude, so you can just put your payloads in orbit by taking them up the elevator. And, I think there are some societies that actually study these things. And so he's been given these particular titles. So the next one is the familiar one. And there he is, Robert Goddard, in Massachusetts, which is where he did most of his work, with this very famous image. Everybody says things are iconic these days. This is actually an iconic image. We've all seen it since we were kids, probably. And there he's standing by the first tested liquid fueled rocket that actually worked. He's standing there with his wife taking the picture. She's almost as important as him because she was with him the whole time through his decades of studies and wrote down everything he did and took pictures of it all. And she was pretty sharp herself. At any rate, here he was in 1926 at a farm outside Boston that his Aunt Effie owned. And so this was launched, burned for 2.5 seconds. Then after getting as high as a house, it turned sideways and went a couple 100 feet and landed in her cabbage patch. And so that was the first actual flight in the world of a liquid fueled rocket. And he added a number of other things through the next couple decades, gyros for stabilization and real payloads and a real recovery system with parachutes. And so he's known as the father of modern rocketry. And then the third one, sort of like Tsiolkovsky, he is what he looks like, is this guy, where if I ever had somebody say, give me a picture of a stern German professor, I think I'd pick this guy out of a lineup. And that's exactly what Hermann Oberth was. And he was really not just an excellent educator, but he was an excellent writer. And so he became famous, not just from what he did in his teaching and who he schooled, as you'll see in a minute, but books that he wrote. And here's the most famous one, The Rocket into Planetary Space, which was so popular in the 1920s that different clubs were set up around the world, including in the US. This is between the two wars. In Germany, he wrote this. It was translated everywhere. And it was written in a popular style so people could start to picture rocketry. And it also had lots of good technical stuff in it. And by the way, you can go out and buy it on Amazon if you want. And in it was the concept for the very famous V2 rocket, which of course didn't exist yet because Germans, until after Goddard, hadn't even tested rocket engines. But then came the time a few years after Goddard when this gentleman, a professor, got a team together at his university and they demonstrated the first German liquid fueled rocket. And he had a very special student with him at the time named Werner von Braun, who was 18 at the time. Oberth was probably 25 years his senior. Nonetheless, when Hitler, and it was Hitler personally, picked von Braun out, obviously with recommendations, in the middle of the 1930s to set up a rocket development team at Peenemünde, which became famous, of course, and the basis for the first operational rockets. Von Braun brought Oberth along with him, in addition to a number of others. And so there you see von Braun in the middle of a bunch of German Secret Service. And in fact, von Braun was an officer in the Secret Service. He dismisses, any connection with them for what their mission was, but he had to be assigned somewhere. And so that was his rank, an officer in the German army there. And so there you see the first test launch in 1943 of this V2 rocket. And it was very successful in test, and so it went operational. And by September of 1944, they were beginning to use them. Now, that was, I think, roughly 7 or 8 months before the Germans surrendered. So they didn't have that long a window, but in that time, not only did they send these into England and London in particular, but across Western Europe. There were many rocket V2s with bombs that were used as weapons during the war. Now, as you can imagine, back in the 1940s, as this was going on, all the nations had their own intelligence services who were trying to figure out how to get at the Germans, because here was a group of German scientists and engineers that had stolen a march on the rest of the world in terms of rocketry. And so all of these spies were going into Germany in 1944 and 1945 and trying to arrange to basically bring these folks out and get advantage of not just their intellectual property, but anything they could bring with them. And the Americans won, but the Russians also won a bunch of German scientists. The Brits did as well, but we got the most of them. And the arrangement that was made, and there are some really interesting books written about this if you ever want to read about it, set up with von Braun that he would recruit all these engineers and scientists. So it was hundreds of them that came out with him. And he was able to go across the border during the war because of his rank in the German army and bring them with him. And they didn't just come as people, but they had literally train carloads of equipment from Peenemünde that ended up in the New Mexico desert. And so White Sands, with the US Army running it, became the home for von Braun's team by the end of 1945. And then eventually they moved him to Redstone Arsenal in Alabama. And the rest is history, as they say. But that's kind of the story of the beginning of real operational rockets. So after the war ended, then these scientists, as I said, were led by him, and they came to various places. And so the V2 was then logically developed further. And I remember as a kid in about 1950 or 51, going to the library to take out the science books and read about the records of these new things called rockets, and see this V2 with a whack corporal second stage, which was built by JPL. And there was this particular launch that became famous because it reached an altitude of 250 miles, which of course is well into space, but it just went up and came down. It didn't go around. So there was no orbiting yet, but this was the record holder for the next 8 years, actually, as far as going into space, the V2 whack corporal. It was called Bumper. And I want to note that the V2 then was the concept that was then carried forward, this multi-stage rocket, into various iterations in the US space program, which began as the missile program, the Atlas, the Thor, the Redstone for the Army. These all came out of the V2 heritage. And Jupiter C was actually our first successful orbital launch. And it was just basically if you will, a civilianized version of the Redstone missile. And you'll see about that in just a second. But the ultimate evolution was the Saturn classes of rockets from the V2. And I will note that those same V2 scientists and engineers that went to Russia were the basis for their development of this series of rockets that they had. And I highlighted R7 there because the blueprints for that were given by the good old communist Russians to the communist Chinese and became the basis for the communist Chinese first rocket, the DF-1. So the V2 had a legacy for the next 25 years, basically, culminating in the US in the Saturn, but also being very important in both China and Russia. So wartime rocketry from von Braun became the basis for peacetime missile development. And we'll see what happened with those missiles that were being developed by von Braun and the Air Force, because now the space age in the 50s is ready to begin. And it began with a very interesting a meeting of some professors. You've all heard of Van Allen. Well, there was an Iowa professor at the University of Iowa, I should say, James Van Allen, who got together with, actually, I think there were some international professors with him, some scientists that were just a peer group, and they happened to get together in his house in 1950 to come up with ideas of what to try to promote to the governments to do in the way of scientific projects. And they came up with this thing called the IGY. Now I'm going to ask another question. How many people read Weekly Reader? Okay. Well, I well remember in about 53 or 4 starting to read about the International Geophysical Year in my Weekly Reader. And it was a plan to head for to be in 1957. And so from time to time, there'd be different projects announced. And this was international scientific cooperation. of probably what we would call the free world at the time. At any rate, in 55, the US announced that part of one of the projects of the IGY was to put up Earth circling satellites. So this was the US planting their flag, even though there had been no satellites launched yet. We're going to do that during the IGY. And the secretive Soviets, 4 days later, decided they'd go public for once. And they threw down the gauntlet and said, yeah, we're going to do that too. And lo and behold, not just to American surprise it was, but to most of the free world, the Soviets got there first. And this was a shock. Some of you are contemporaries and may well remember how this hit. I'll never forget it. I was in junior high, but it was on the news and it was in the newspaper. And I can remember the day actually that this announcement came out and we all were kind of saying, what? You know, the US hasn't done this, but they're able to do that. And the Cold War was raging. So it was extremely worrisome and led to quite a few changes in the educational system across the US, sort of, if you will, a pre-STEM STEM. At any rate, so when this happened, there had been, since the beginning of the 50s, the selection of the Air Force, the new service, to develop the Thor and the Atlas ballistic missile. And the Army was given the charter to develop the Redstone. And at some point, the Navy was given the charter to develop the Vanguard. Well, for whatever reason, when this happened, the powers that be said, Navy, you guys finish up because we think you can get there first and get a satellite up there as quickly as possible. So from October to December, the Navy got a Vanguard ready for launch, and there it is. And so it became known by the media as Kaputnik, as it blew up on the launch pad. And von Braun probably was chuckling because it was sort of an I told you so. He was claiming his team could get there first, and they were given the opportunity then. So after 2 months, the Army was given the chance, and von Braun's team got there with something called the Jupiter C, which was just the Redstone missile made into a space rocket. And what you see there on the left is the upper stage and the payload being held aloft by, on the left is the director of JPL, who built the upper stage. On the right is von Braun, and in the middle is none other than James Van Allen, who has the experiment on board. And so what is this? 8 years after he got a bunch of folks together in his living room and then decided to petition the government for some projects, he got to have his scientific payload. Well, Sputnik was by far the most important, but all it did was go around and beep and be visible to people that wanted to look with binoculars. But along, 4 months later came the US, who actually had a very valuable payload on board in our first launch, because it did, in fact, get to the what became the Van Allen belts and make measurements up there. So, and I haven't ever mentioned a civilian agency because there wasn't one. So months after this, it was decided that we needed a civilian space agency, and that's when it became National Aeronautics and Space Administration. So after 1950 scientific cooperation, we now entered the space race with 2 nations having their own Earth orbiting satellite capability. So NASA was born in July. By October, which is kind of interesting, only a few months later, they decided to declare a manned space program. By this point, there hadn't been very many unmanned launches, but they knew that that was something that people would want. And it was named the Mercury program. And the people that were going to fly it had a new name that nobody had ever heard of called astronauts. And so that became a pretty big deal, the Mercury 7. In, what is that, about 7 months later, they announced the Mercury 7, who they were going to be. And you might wonder why I would note that Life magazine talked about it. It was a different time for media back then. And so the government wasn't really good at doing PR. And so they let all the media outlets bid to have exclusive coverage of this new Project Mercury because they knew the public would be excited about it. It wasn't a military program, it was a Getting Man into Space program, which was very exciting. So Life magazine got the contract. And so here's the first issue that showed these Mercury 7 astronauts. And there you see them. And I want you to note two things. First of all, you can't see this, but they were all military and they were all test pilots. And if you talk to Ike, or actually Ike said, that of course is where you will go get the Mercury 7. He didn't have any question about it. We're not going to go get some civilian guys. We're going to go get military people that know how to fly under pressure and get the best of them from the test pilot schools. So what we've got there is a combination of Marine, Air Force, and Navy test pilots. And the other thing to notice is they aren't in uniform. And that's because Ike and the rest of them also didn't want the world thinking of this as a military program. They wanted them to be viewed as just some civilians that we're going to put up into space now, even though they were all officers in their services. And then within weeks came another issue because a lot of the human interest story was about the families. And so the women all got their feature, and there they are. And now the thing about what you see with the men there in civilian clothes is they're all just military officers, which I was once. It doesn't pay that well. But these guys, every time they got near somebody in the media, they wanted to stick a mic in their face. Every time there was a convention, they wanted to invite these guys to come and speak. And so they had to go in their civilian clothes. The government wasn't paying for any of this. So they needed some money for all these new clothes that they were going to wear and this travel that they were going to have to do. And so Time Magazine, as part of our Life magazine, split up $500,000 across the 7 couples. So they each got about $70,000 to cover things like travel and civilian clothes because they were going to be in the spotlight. Now, $70K doesn't sound like a lot now, a couple, 3 cruises maybe. But back then, that was a lot of money in the 50s. So they needed it. So that finally they announced which of the 7 would be the first to fly. They're the names that you've heard: Glenn, Grissom, and Shepard from left to right. On the left, a Marine; in the middle, an Air Force officer; on the right, a Navy man. So Kennedy was what? A Navy man. So guess who flew first? Yeah, the Navy. Alan Shepard went first. The Air Force went second. And they both went not into space. Well, they went into near Earth space with a suborbital flight. And then the first one that went into orbit was John Glenn. So that's now early 62. And now this was the space race was on, but it has man in it. And now what happened to make it into the moon race? Well, in those first few years, there were lots of orbiting satellites by 1960 or so, but we had designs to get beyond Earth orbit, as you're aware, and I think I talked about at length in one of our lectures a few years back. At any rate, we, of course, didn't want to go the millions of miles away before we stopped off at the nearby place, only 250,000 miles away. So we and the Soviets were targeting the moon. And so the first lunar probes and orbiter were finally successfully, they were able to get to the moon, they were able to orbit the moon, and that was the Russians. Okay? And we hadn't. The first human was put into space, and that was Yuri Gagarin in April, and we hadn't. But we finally, a month after that, put Alan Shepard up. He didn't go into orbit like Gagarin, but we did finally have a spaceman. And so now, here's what happened. Think about this. We had not yet had any successful missions to even send a satellite or a spacecraft to the moon. They'd all been failures, and we tried a number of times. we had an astronaut that hadn't yet orbited. And about 2 weeks after that, if this works right,
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish. I believe we should go to the moon. But I think every citizen of this country, as well as the members of the Congress, should consider the matter carefully in making their judgment, to which we've given attention over many weeks and months, because it is a heavy burden. And there is no sense in agreeing or desiring that the United States take an affirmative position in outer space unless we are prepared to do the work and bear the burdens to make it successful.
well, here we have bipartisan Congress standing up and cheering. You seen that lately?
There was a Gallup poll before Kennedy.
So I won't play the rest of it, but what he's saying is, I'll just summarize. Within about a month after this, Kennedy was recorded talking to some of his confidants saying basically that they'd looked at the cost of it and he just really didn't think it was reasonable to spend the money that it would take to get there by the end of the decade. He's already announced that we're going to do that. But if you were paying attention, and I won't play it again, while he gave this address, he went into his kind of professorial way of saying, and of course, if we are going to do this, then we have to face the fact that there will be challenges ahead and there will be great resources required. Well, the fact is, he wanted Congress to consider whether or not this was something and get on board with him if they were willing to pay for it. The other thing that says after this is that there was a poll taken about 2 weeks before this address asking Americans how they felt about spending $40 billion on a race to the moon. And a great majority of them said they didn't think that was really something that would be worth it. So that was the beginning of deciding to go to space. So let me see if I can go on to the next.
In May of
slide here.
61.
Okay, so now we'll finish up with Mercury 7, which started with those three that I mentioned. And there were 7 of them. Deke Slayton, it turned out, had some medical issues that kept him from flying until the 70s. And so 6 of them flew eventually, and you see the other 3 there. They all orbited like Glenn had orbited. So the Mercury 7 program, very successful, announced in what was it, 58? They were named in 59, and 6 of the 7 had flown by early 63. Pretty successful program. And so now you see another picture with the Mercury 7 there in the front row. Can you hear me all right?
Yeah.
Okay. And behind them, you see the first of the next program's selectees. The next program was going to be a 2-man capsule, hence the twin Gemini. And it was going to be for particular reasons that were a stepping stone to getting to the moon that we'll talk about real briefly. But at any rate, I won't go through who the next 9 added were, except to say on the left there in the back is a guy named Ed White, who you may have heard of. He was the first spacewalker that the US had. And third from the right in the back row is a fellow named Neil Armstrong. So these if you will, classes of new astronauts are being announced now. And so the idea of Gemini was to put up a capsule in Earth orbit that would demonstrate a couple things: the ability to work outside the capsule and the ability for for 2 space objects to have a planned and successful rendezvous, and also a physical docking and undocking, because all that was going to be part of the Apollo program. So we needed to demonstrate it kind of on an easier program first. Well, once again, in the spirit of everything else in those times, the announcement came in like 62 or 63 to set up the program. And it was done by the end of 66 here with 10 missions in, what is that, about 18 months flown by 16 astronauts. Well, 2 per capsule for 10 missions sounds like 20. So 4 of them actually flew a couple times. And one of them is very famous, and you may have seen this in one of the movies that's been out there, because Neil Armstrong is one of the Gemini astronauts, ended up in a particular flight where they completely lost orientation at one point. And the test pilot in him had to keep cool while they were becoming not just disoriented, but almost nauseous on board, and figure out how to slow it down with the retro rockets and get it back, and he did. And I don't know this, but I'm guessing that that didn't hurt his chances of being the first person to go up in Apollo, because he was really cool under pressure. So Gemini, as I said, demonstrated rendezvous and docking. On the right there is the Gemini capsule on top of the propulsion system. And on the left is a vehicle that it's docking with, known as an Agena spacecraft. Now, I launched several of those Agenas. It was a very popular second stage back in the 60s. So it went into orbit, and then the Gemini went up and rendezvoused with it. And as you see here, it docked. Some feedback standing right here. Is this any better?
Yes.
Okay. Which is basically a dry run of what they were going to have to do on Apollo with the command module and the lunar module to do docking and transfer of crew. And the other thing was, there's Ed White now on the first US EVA, extravehicular activity. They demonstrated that. So finally, we're to the Apollo program, the third in this series of programs to build up to the moon. And so the astronauts were chosen now, not just from that first group in the upper left, but 3 more classes, if you will. And I'm obviously not going to go through them all. I'll note with those 3 red asterisks that you could see there in the upper left, the 3 Mercury astronauts that got to fly in Apollo as well. And among the rest of them, they're not all military, they're not all test pilots. And one of them, in fact, Harrison Schmitt there in the final group, is a PhD geologist. If you're going to choose a scientist to go to the moon, you probably want to choose one that can do something with rocks and you know, the lunar soil and so on. So that's the first scientist astronaut. And there, of course, is the famous moon rocket. The 5 F1 engines, each with 1.5 million pounds thrust for 7.5 million pounds total, lifting a 6.5 million pound, basically 35-story building off the ground, and the most powerful rocket ever at that point by far, and a direct descendant of von Braun's V2. So we'll go through the missions pretty quick. Now, Mercury was fast, Gemini was even faster, and Apollo started very fast. And what happened then was, maybe it started too fast. So you see, we selected the first 3 astronauts for the first Apollo capsule, who were going to go to demonstrate the Apollo capsule for the first time, of course, in Earth orbit. Grissom, Ed White, and Roger Chaffee. And here's another picture of them. And so you might wonder what they're doing. What they're doing is praying. And they're praying over the Apollo 1 capsule. All the astronauts go to the contractors that are building the rockets and the capsules to do multiple things. Obviously, one of them is to answer questions to help them finish the design. Another is to go in and test things to see if it actually is good in terms of human factors. But one of the things they want to do is they want to kick the tires of everything while it's being developed. Well, they went to the contractor for the Apollo 1 capsule, and they got really worried. And they got worried about all the flammable material inside, because they knew what kind of a small enclosed environment it would be. And lo and behold, in a launch rehearsal test with a pure oxygen pressure environment, electric spark caused a fire. After they had sent that picture to their management to say, please be careful about this risk, it's what killed them. So if you've ever heard that NASA management sometimes gets questioned as to whether or not they really are being careful enough, there are a couple instances where they haven't been, and that was certainly one of them. At any rate, very, very sad event, but perhaps worst of all, or maybe it had a silver lining, it slowed everything down completely. Kennedy said, we're gonna get up there by the end of 69. This was a test, this was now in 1967, and we haven't even gotten a capsule complete or astronauts into a test. NASA said, we'll look into it immediately, we'll study it in detail, we'll come up with fixes, we'll get right back to you. And they did. And within a few months, they had their study, and Congress said, thanks very much. We actually think an independent viewpoint would be a little bit better at this point, since you guys designed it and picked the contractor. And so the Congress chartered a different study, and it took much longer. So that by the time the studies were done to decide what fixes to do to make sure something like this couldn't happen or lower the risk, there was only 20 months left in Kennedy's window, a little over a year and a half before the end of 69. And we were just finishing up the post-mortem of what happened in Apollo 1 so the program could move forward. Well, once that post-mortem was done, everything was approved, things moved fast. So now Apollo 8 became the next mission, which was one that changed just a couple months before the mission happened. They completely changed the mission because our intelligence told us that the Russians, remember them? We're in a race with them. It's the Cold War, the world's watching. And so our intelligence was telling us that the Russians might get to the moon by the end of the year. So they changed the Apollo 8 mission to send 3 astronauts up to the moon. And so I think probably many of you remember this particular mission that wrapped around Christmas time in 68, where they not only were able to take an image like this, and they were the first men ever to go to the moon and orbit around it, but they took along their Bible and they read from the creation story for all the world to hear, as in a pretty moving Christmas Eve communication. Next came Apollo 10. There was Apollo 9 was just an Earth orbit one. Apollo 10 then was the dress rehearsal for the landing, where they did everything except land. They took the service module and the command module and the LEM up in the lunar orbit. They separated the LEM. They rendezvoused with it. They transferred crew. The crew got in the LEM, separated, went down towards the moon, and they got down to about 10 miles above the surface and stopped and looked up close at the moon, and then came back up, rendezvoused with the command module, and came home. Can you imagine how that must have felt? At any rate, the story goes, and apparently it's true, NASA management told Cernan and Young, the 2 guys in the LEM, that they'd only put enough propellant on board the LEM to do this, and that if they went down to the surface by accident, that they wouldn't have enough propellant to get off the surface. And, you know, they're test pilots. They want to push the envelope. Whether it's true or not, apparently, at least it worked in terms of not having them land, but it was a completely successful dry run of everything, the docking and undocking, the return to Earth, and so on. Then came the main event, and we've all heard a lot about this, so I won't go into much detail on it. You know the astronauts, Neil Armstrong and Aldrin were on the surface, and there's always a third guy who orbits around the moon. And you may have heard during the Artemis transmissions, we kept hearing about these are the first times that humans had ever looked at the other side of the moon and everything. Well, except for a whole bunch of guys that orbited around the moon over and over again during Apollo and looked down on the other side of the moon.
But their view was limited.
That's true. Their view was limited. It was different. This is true. Different caps and different altitudes. Then came Apollo 12, and this is the way things happened in those days. I mean, this phenomenal accomplishment of a manned landing, and only a few months later, we get another one up there, also very successful. This one happened to be targeted and came down right near where one of the Surveyor spacecraft that we had put down on the moon while we were looking for different landing sites had landed and scouted one some years before, and they landed right there and brought back some pieces of it. Then came the second most famous mission with Tom Hanks and Paxton and Kevin, I'm sorry, wrong one. With Fred Hayes and Swigert and Jim Lovell. And we all got to listen to that. That was a real edge of the seat kind of a week to see them figure out how they could come back and stay alive, actually. It was quite a heroic mission. And it was a tribute to the LEM that they figured out a way to use a propulsion system that hadn't been planned for returning the capsule to Earth at all, but it worked just fine. And there you see when they finally did undock the command module from the service module, on the side of the service module, the explosion inside had blown a whole panel off the side of the service module. So it was not ever going to be able to bring them home. And then 14 happened, and not surprisingly, their landing site was the same one that 13 would have had. Then we had finally the last three, as it turned out, Apollo missions that were quite different from the first three landings in that each of these guys had wheels. And so the first cruise, and especially Apollo 11 walked around the spacecraft over to the edge of a crater and so on, the distance that you can achieve by standing on an aircraft carrier and going over to the edge and the fantail and so on. So those first three guys stayed pretty close to home and they were just walking. These guys now all had lunar rovers to drive around in. And so they drove not just short distances, for tens of kilometers in a couple cases, for as close, and they were doing their extra vehicular stuff outside of the lunar module for approaching a day in each case. So lots and lots of ground was covered with Jack Schmitt, the geologist at Apollo 17 there. A lot of special rocks came home on that last mission. And I think the amount in total for the 6 missions was approaching 0.5 ton of moon rocks, many of which are still in storage, carefully stored, and haven't even been, studied yet. So it takes years for all this material to be carefully studied. So that was the last Apollo landing, and people like me in the space program, but all people around the world probably were very surprised as the years passed that we weren't doing anything to even think about going back there after we did all this over a period of just a few years. But let me summarize that particular moon race, since we're in a different one now. I showed you this part before, up to where Shepard finally got up in space and Kennedy made his announcement. Then came another, finally we had a success with the moon about 3 years after Kennedy's announcement, where we had, 8 years at that time. Well, it took us 3 years just to have a successful launch to something to the moon after 13 attempts. So things didn't come that easy. And then the Russians had the first soft landing, we didn't. And then we had finally ours, again, only 3 years before Apollo was supposed to take people to walk on the moon. We finally had something land softly on the moon. So things happened very fast. The overall scorecard for the 60s for the moon race, 65 attempts were made in an 12-year period there by the two nations. The Russians had a few more than us. We had a few more successes than them, and we won. And that was a huge deal. To my knowledge, to everybody's knowledge, it may or may not be true. Russians do things in secret. They never actually did try to put somebody down on the moon. They had plenty of spacecraft that went. So now we get to the post-Apollo phase and what happened in the interim. And so we thought there'd be some lean years because it had been very expensive, but they turned into very lean decades. So here's a 30-year period. And the first things over there at the left were all the Soviets. They orbited a Luna. They landed a couple on the surface again. As far as we know, they never tried a manned landing. And then there wasn't much going on in the eighties. And here's a Japanese spacecraft in the early nineties that went up to orbit. And the US, oh, and a big change came in 91 because there was no Soviet Union anymore. And as you're aware, the Russian space program has been literally a shadow of its former self since then. So we didn't expect to see much more from the Russians, and we didn't. And then we had several spacecraft starting in about the mid-90s. I talked to you about in a lunar science lecture about those. And the Europeans got a spacecraft up there. And this brings us up into the beginning of this century. And then for the next 13 years, out to 2019, we had a number of very successful and useful moon science missions. And so here's one, the upper one there is the Lunar Reconnaissance Orbiter, which has now been up there for 17 years. It's still taking images and measurements. We've mapped the moon in high resolution everywhere now. It's just amazing the database that we've built with LRO. And the one that you see down at the bottom there is the L-Cross, which was sent into a shadowed crater down near the South Pole and followed in with a measuring spacecraft that took pictures of the splash that it made or the cloud that came up when it impacted and measured the material and found lots of ice in that material. So that's a lot of the basis for how we're calibrating how much water there might or how much ice there might be available in these craters on the moon. Very important missions. And then the Chinese started to get into the act. And they have a series of spacecraft called Chang'e, which I'm told means it's Chinese for the moon goddess. And Chang'e 1 and 2 there orbited. Chang'e 3 landed on the surface. And then in 2019, they achieved something that nobody else had, which is to land on the far side of the moon. And they had to have some kind of relay because they were able to get their radio signals back and give us some of these wonderful images. So there's a picture of the Chang'e 4 spacecraft, the lower part of this image, panoramic there. And right about in the middle, you see its little rover driving across there, leaving tracks on the far side of the moon on the lunar surface there. And that's the, it's called U-2, that little rover. And there's been more. That was 2019. In the last few years, they've had 2 more missions successful. Their first lunar sample return, again, a robotic spacecraft, and a sample return from the other side of the moon, which has now put another rover on the other side of the moon. So the Chinese are really coming along fast. And you're probably aware they're targeting 2030 for their manned mission. All right, so we finally kind of, I won't use the colloquial terms, we got underway with an accelerated lunar manned program in 2017. It had been close to a decade where we had been building the SLS, the moon rocket, and the capsule, but there hadn't been a stable plan for what we were going to do and a push. And this one was given the name Artemis, which is Apollo's twin sister. And it was by statement in 2017 going to put American boots back on the ground by 2024, which is not coincidentally the end of what Trump thought would be his second term. Okay. These things, you know, they're there for a reason, these targets. The target for the current mission is 2028. So that was the plan. The plan was to put 2 people down on the moon at the moon's south pole, as it says here. Here's the rocket, which we've talked about before. Lots of heritage from the shuttle program to mitigate the risk. The 4 liquid-fueled engines on the core vehicle are from the shuttle. The 2 solid rocket boosters on the side were used in the shuttle. They're longer. They've extended them, so they burn longer, but it's the same rocket propulsion technology. And the new thing is the Lockheed Martin Orion capsule. And so the plan, as it says, was to have Artemis 1 in 2022. Well, that actually did take place. It was at the time in 2022, the most powerful launch ever, 8.8 million pounds thrust, which now has been pretty much doubled by the Starship a few times. And then the plan was to put Artemis 2 up this year, the first crewed mission, and there's the trajectory. And the plan was that after this year, next year, we would put people on the moon. That was the plan. As you're aware, we had a totally successful Artemis 2 mission, really did go exceedingly well. And beyond that, there are big changes. So let's give some credit. I won't dwell on this because you've all heard a lot about it lately. But here are the 4 astronauts. Reed Wiseman and Victor Glover were flying it. And Christina Koch, an American, and Jeremy Hansen were mission specialists. And they flew for 10 days. They went further than any humans have gone before, as you've heard. And it was a totally successful mission. That's the very important things, in addition to the fact that it turns out Christina's quite a Philadelphia sports fan. And so if you weren't aware, she took a bunch of confetti up there to the moon, or to around the moon. And in her ISS missions, she's very frequently had on Eagles garb and things like that on the International Space Station. So I thought that was worth noting. All right, so the plan for the mission that was to put people on the moon next year, this is a review, we've seen it before, was to use the SLS, which we've now demonstrated successfully with people on it, and to get a human landing system up there for the Orion to dock with to take humans down to the lunar surface. And the human landing system is a huge deal. And SpaceX has had a contract for it for several years. And SpaceX, who pretty much never puts a foot wrong, has not put their feet anywhere on this particular one in terms of meeting schedules, because the idea was that all those rockets on the left there would be super heavies with starships on top of them that would take propellant up into low Earth orbit to fill up a propellant depot, so that it would then take a human landing system up into low Earth orbit, get its propellant from the propellant depot, and then have enough to go through its translunar injection there and rendezvous with Orion, take the crew down to the surface, land vertically. That's the SpaceX HLS concept. After the couple weeks of exploration, come back up, transfer the crew back to Orion, come back to Earth. So there's a huge role for SpaceX now in the lunar program. As I said, I think a year or two ago when I talked to you about this before. And the thing is that SpaceX hasn't met their milestones with their super heavy and their Starship rocket. They've finally succeeded in doing the version 1 level, and we're waiting to see when they're going to launch the more powerful 2nd generation. But really what we're waiting for is when it's operational, so they can do a whole bunch of low Earth orbit missions like that. All right, so the plans have changed. As it says up on top there, there's a new Artemis 3. It's not going to be done that way. Along came a new NASA manager, Jared Isaacman, who frankly I think is an answer to prayer almost. This is a young man who has been very successful as an engineer and a technical manager, managing extremely large technical organizations, which sounds a lot like what NASA needed, and to meeting milestones, to becoming very wealthy as a young man and buying his own space missions and going up into space twice himself. And if you didn't get a chance to see him, I think it was 2 or 3 weeks ago now, their YouTube presentations that NASA gave literally all day, where Isaacman started them off and finished them with 2 or 3 of his top senior managers to talk about the new lunar programs. And it is pretty impressive stuff. They've inserted a new Artemis 3, which is essentially a risk-reducing mission. Just like Apollo did, stepwise, You try things out in low Earth orbit before you try them out at the moon. You try them out there before you put them down on the surface. So they've now put in a new mission to test out this human landing system before we believe that it's going to work completely when we send the SLS up to the moon with Orion. And so next year, and this is very challenging, there's to be a demonstration in low Earth orbit of human landing systems, because they have given new contracts to both SpaceX HLS, who were behind schedule, but also Blue Origin, who had a schedule to build an HLS for a later Artemis mission. So now they're both accelerated, and they're basically in a horse race to see who can have a viable one to demonstrate next year. So stand by. That's pretty incredible challenge. And there is a new sheriff in town, and he seems like he's able to very seriously deal with these folks and push them hard. So Artemis 4 now is to be the first lunar landing. It's supposed to happen in 2028. As I said before, that's coincidentally still in this administration, and we'll see whether it happens. But the point is, we haven't heard any details about it, and obviously they can't really do that until they have a human landing system that's been demonstrated. Okay? Thank you.
Thanks, John. That was a great talk. Any questions?
Yes, sir.
Few weeks ago, it was announced the Artemis was the furthest humans to venture beyond Earth. But correct me if I'm wrong, because of Apollo 13's disaster, they had to make a wide loop around the moon, and Artemis made it out to 252,000 miles, but Apollo 13 made it to 248,000 miles because they had to make a wide loop. Am I correct with that? That you gotta give credit for 1970 that we made it that far. We're splitting hairs here, right?
Well, the way I've looked at it is, Edmund Hillary climbed Mount Everest. And this is sort of like the folks that went back 20 years later and took a ladder up and climbed a little higher when they got on top of Everest. It's truly a record. That's true. Is it a big deal? It's a big deal that the Orion operated perfectly. Well, I shouldn't say that if you had to, think about all the human functions. But at any rate, as a functioning spaceship, if you will, it operated great.
Other questions?
Yeah.
That truly was an excellent talk.
Thank you.
What is the story on the heat shield? Has that been studied by now?
The only thing I've seen, I think I saw it 2 days ago, was that NASA's reported that the heat shield functioned just as expected. So does that satisfy you?
Yes, it does. Thank you.
For those of you who don't know the inside story of that, the heat shield's what we were all worried about. Because the one other time it flew in Artemis 1 in 2022, there was a lot more damage to the honeycomb that's not supposed to break up quite as much as it did from the reentry. And so most of us expected, because Lockheed went hard into testing that out and coming up with a new design, and they did. And the new design will be used on the next mission. And the one that was a problem from Artemis 1, they used exactly the same design. And so what they did was, when you re-enter, it's, the astrodynamicists have to figure out angles and trajectories and so on. And so it turns out that what they did with Artemis 1 was they allowed it to slow down by skipping some like this. And for whatever reason, they calculated, and they had empirical data that showed that there was a problem with the burning. So they decided that they'd have a different re-entry. And so they came down at a steeper angle and went deeper, which might sound like it's worse, but it turns out that the integrated effect of it is less. And so whether or not that's, it performed as expected might mean that, yeah, we just got through by the skin of our, whatever. Or whether, maybe the report will come out and say the design of a different approach to the atmosphere worked out perfectly and there were no problems. I hope that's the case. Yes, sir.
Thanks for coming again, John. Was the main reason the Russians abandoned their lunar aspirations was because of Apollo 11? Was that the main reason?
Who knows, but I believe that above everything else, the Apollo success was winning one particular battle in the Cold War that happened to be in the space theater. The Cold War had many things where things came to a head, Cuba and some others, probably some we don't know about. But one of the theaters, I believe, in the Cold War was space. And once we'd won the principle, we'd taken the hill, I don't imagine that they had a lot of appetite for spending a bunch more billions on their program to be second.
Did they have a lot of failures with their rockets?
I don't know. I don't know. I don't.
Be sure that
Okay.
it blew up.
I see. Okay. I don't know. Yes, sir.
They had a number of failures with their rocket. One of the big issues they had was there was a lot of dissension within Roscosmos, and they couldn't get large rocket engines. So if you look at photos of the old moon rocket, the N1, it's got all these little engines, and the difficulty was they didn't have the computerization like they did in the United States. So they didn't have control of all those engines the way they should have. So they had 5 major failures, which remained secret for years and years and years. It was only the 80s or 90s that all that came out.
Yeah, I mean, with the Saturn, we had 5 F1s that were arranged with a center one that was fixed, and the other 4 were gimbaled, which meant that you get pitch and yaw and roll with 4 engines, and it was simple enough that way.
Hey, John, I had a question. No, that's gonna make it. The SpaceX Starship, it's my understanding that was using methane rather than kerosene as the propellant, right?
Yes.
Why do you think they decided to use methane rather than the traditional kerosene? I mean, seems like that was the bulk of their problem, because NASA had tried methane historically, and that was a lot more difficult propellant.
You know more about it than I do then. All I did was read about the, what's it called, the Raptor? Is that the engine?
Yeah.
Yeah, it's a Raptor, which is a methalox, as they say, engine, methane and liquid oxygen. And what I read was that they wanted to use methane, and incidentally, Blue Origin with the New Glenn is exactly the same thing. The new engines are using methane because I'm told it's a higher energy fuel.
Yeah, I think it causes more cavitation, and it tends to cause hiccups in the thrust, and I think they've all had that problem.
Well, but they have a new approach called, let's see if I can remember the way they word it, I could look it up, but at any rate, they have a new way of handling the feed of the 2 propellants to the combustion chamber. They pre-burn both of them and use that pre-burning to drive into the final combustion chamber. It's full flow is what they call it. And it's a new, more efficient approach, and it works. And it's the best, at the moment, it's the most efficient approach.
We live down in Delaware now, near Rehoboth, sometimes on the beach, and we have Marsh is our really good producer of methane. So if anybody got to go in business with me selling that to SpaceX, we're gonna put a pipe in my backyard.
Very happy up there.
I believe one of the issues is the methane does not produce the ash that the kerosene does. So when you're using reusable rocket engines, it's much easier to maintain them using methane.
But I know they historically have a lot more problem with cavitation and
Right.
having
It's a, yeah, it's very, yeah, it's very difficult to store and very difficult to use. Yeah, much more difficult than kerosene.
All right, any other questions? Now, I might be remembering something different, but I thought in Apollo 11, they did have some trouble landing and Armstrong did have to take over manually at one point. Was that correct?
I don't remember. Don't remember.
I thought there was something that they found there were a lot of boulders or the area where they're supposed to
Oh,
land.
I'm sorry,
was not
land,
level.
I'm sorry, I thought you meant on return. Yeah, oh yeah, that's exactly right. And they got this computer error. And it mattered because they wanted to be flying with the computer and not manually, and yet he was trying to extend the range because of the boulders. And the computer error was one that had them really worried in the last 30 seconds. And there was, as the story goes, and I may have the details a little wrong, but this was back at the time, there was a young MIT engineer there that knew exactly what that error meant, and it meant nothing. It just meant that the storage had to recycle or something in the computer and was not actually a problem. And so the launch director was told, go right past that, ignore that. Yeah.
All right, anything else? All right, if not, let's thank John for a great talk.
Thank you.
Well, thanks, John. It was a great talk. And thanks everyone for coming out tonight and have a safe trip home and see you again, maybe at the Star Party Sunday if it happens. If not, I'll see you here next month. Take care. Good night. Thank you very much. So.